All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. And we are here to continue with the physics of the NEET examination. So, very good evening to all the live students. I hope you can hear me and see me properly. Yeah, yes or no? So, the live students can respond to me if you can see me and hear me properly. Yeah. All the live students, very good evening, and welcome back to the session. So today, the session I have kept at 5 p.m. Okay. So the live students, very good evening. Do you wish to say good evening or something? Okay, that's okay. That's okay. So guys, in this session, so in the last session, we have dealt with the differentiation. Okay. So in the last session, we have seen that how we can do the differentiation, what are the basic rules of differentiation. So in today's session, basically what we are going to do, we are going to apply those very concepts. We are going to apply those concepts over the kinematics. Okay, over the kinematics. So till this session, what we have completed. So before I get to that, let me introduce myself. So my name is Dr. Shankar Sir, and I am your physics educator. These are my brief credentials, and let's come to the point. Okay, because time is crucial. Okay, so guys, now please observe. So in the last session, we have spoken about, so in the kinematics last session, that is motion in a straight line 2. So guys, on this channel, we have already completed the first chapter or the first unit, that is units and measurement of your NEET syllabus of physics, and we have started the kinematics. So in the last session, guys, we have concluded about average velocity, average speed. We have spoken about it. Then further, we have talked about the differentiation, that how much differentiation is required for the NEET preparation. We have done that, and now in this session we will be talking about a concept. So for which we have learned the differentiation, that is the concept of instantaneous speed and velocity. Instantaneous speed and velocity. Okay. Okay. So now please understand this. So see, this is very simple. Now once you understood the differentiation, this is not going to be, seems to be very difficult for you, I hope. So sir, we have learned that average velocity is the change in displacement upon change in time, right? Okay, but when we were talking about the average velocity, this time difference was significant, and it is, we can call it is a infinite. It is not infinite, but finite time difference. So when we are seeing the velocity or speed in finite time difference, we call it average velocity or average speed. But what about it being the instantaneous? So we know this is what we know as the change in time, right? So this is what? This is the change of time. Okay. And this change of time is finite. It is quite big. Not that big, but it is big enough. Okay. Big enough. Now, if this change in time, now please understand this. So if I am, somewhat, stopping the time, okay, like I do not want the velocity in some change in time, but I want the velocity at some point of time. Like that is, what is velocity exactly at 2 seconds? What is velocity exactly at 3 seconds? So you see, there is no change in time, but we are, practically seeing it at some point of time. Okay, we are practically seeing it at some point of time. Now, under that condition, what is going to happen? Under that condition, what is going to happen? So, what we can say that when we are seeing the 2 second, when we are seeing exactly at some point of time, what is going to happen? That we have reduced the change in time in a very small quantity. Okay, very small quantity. Let it be like we are seeing the change in 1.9999999999999 second to 2 seconds, because velocity is something which defines on the basis of change of time. So what we do when we are seeing instantaneous velocity, and same for instantaneous speed, and speed is just the magnitude of it. Okay, in this case, now when we are talking about the instantaneous velocity, when we are talking about this instantaneous velocity, what is going to happen? This delta t, you are going to make it very, very small. You are going to make it extremely small. So when something becomes extremely small, you can say that it is reduced to a differential entity, a differential quantity. And similar for it, this change of velocity also becomes that ds. So we know, we have already spoken about it, that dt is something which is very small. This is something very small. So when we are seeing the instantaneous velocity, basically we are seeing the velocity at some point of time, at an instant of time, and to see that we are reducing the time to a very small quantity. That is a differential quantity. Okay, that is a differential quantity. So what is instantaneous velocity? It is ds by dt. Now very interestingly, one thing we can understand from here. So what we can understand from here? What can we understand from here? So that we can understand from here. We can understand from here that, so ds by dt it is written. So in differentiation, we learned that the differential. This is how our differentiation is represented. So previously in the differentiation, we learned about the dy by dx. So what is the dy by dx? So it was the slope. It is the slope of curve. It is the slope of curve. Okay, it is the slope of curve in x and y. Now similarly, ds by dt. So it is the slope of curve in s versus t diagram, isn't it? S for displacement, t for time. Okay, so this is the normal nomenclature we use. Okay, what do we use, sir? So we use s as displacement, t as time, v as velocity, a as acceleration. Understood? A as acceleration. So ds by dt is going to be, it is the slope of curve in s versus t diagram. Okay, s versus t diagram. Now please tell me this ds by dt is also the, very interestingly, it is also the instantaneous velocity, isn't it? It is also the instantaneous velocity. So can I say that the velocity at an instant, that is at a point of time, is nothing but the slope of the s versus t curve, right? It is the slope of s versus t curve. Do you agree to it? Do you agree to it? Yes or no? Okay. Now, please understand this is why we are requiring this, because see, we always want to know that what happens to the velocity to some changes of displacement with respect to time and vice versa. Lately, we are going to talk about it also. So let's try to have a feel of it. So let's suppose we are having s is equal to t square. So if we are having s is equal to t square, now if I want to see it, so what does it refer to? So if I write time here, and if I write, displacement here, so can I say that when the time is 0, displacement is 0, when time is 1, displacement is 1. Now, when time is 2, displacement is 4. Now, the time is 3, it is 9. When the time is 4, it is 16. When time is 5, it is 25, and so on and on and on and on. Right. Now, if I want to represent this thing over a curve, over a displacement versus type curve, what shall we do? So when the time is 0, displacement is 0. When time is 1, displacement is 1. When time is 2, now displacement is 4. Okay. Now when the time is 3, the displacement is 9. And it goes like that. It goes like that. So you know that this is going to be the curve, right? This is going to be the curve somewhat like this. Okay, somewhat like this. So lately, in the upcoming session, we are going to understand the plots also, the graphical representation also. We are going to see displacement versus time, velocity versus time, and what not. All these graphs are we are going to see. but to have some, feel of it, can we say, like, sir, if we want to know the velocity, we can simply see the slope of it, right? We can simply see the slope. So here you can see that the slope is increasing because the theta is increasing. So we have learned from the differentiation. Hello, Shrisai. So today I have planned the class at 5. Okay, at 3 there was some urgent thing that we have to take care of. So sorry, I have planned it at 5. I hope it is fine to you. So in the last session, both live are going simultaneously. Okay, no worries. So you can join once that session is completed, because I think Harsh sir would be going to end it very soon because he has to start the summer, right? Okay, okay. So right, will that be fine? Okay, so from the next session, me and Harsh sir will definitely take care of it. We'll coordinate more, right? So that you won't get this trouble again, right? But now see, so you see, so these two what are happening. So here, I can see that this slope is increasing. So if slope is increasing, that is tan theta is increasing. So when slope is increasing, guys, when slope is increasing, that means the velocity is increasing. Okay, and this is something you can see from here. Na? This is something you can see from here. So you see that the displacement is increasing more and more and more and more with respect to time. But what you can do every time, are you going to make this stable from the curve? No, sir, it is not possible. This is not possible. So when this is not possible, from the curve itself, you can directly interpret. Okay, directly interpret this thing. Okay, okay. So one important point here, what we got, that's the slope of the displacement versus time curve, that is ds by dt, is going to give us the velocity. Is going to give us the velocity. I hope it is fine to everyone. Okay, okay. Now let's solve some problems. Okay, so if you are good at differentiation, this is not going to be any of any worry. So let's suppose s is equal to t square. Now what we want? So we want the velocity at t is equal to, let's suppose, 1 second, t is equal to 2 second, t is equal to 3 second. Okay, we want velocities at these points. Okay, and let's add on one more thing. So okay, so we want velocity as well at velocity, or I can say what is the average velocity. So this is the first part of this question. Now the second part says what is the average velocity, between, what is the average velocity between 1 and 3 seconds. What is the average velocity between 1 and 3 seconds? Remember, this is not 5. Sometimes my S look like the 5. So don't get confused in that. So what is the average velocity between 1 and 3 seconds? What is going to be the average velocity between 1 and 3 seconds? So these are the two parts of this question. Let's try to solve this. Now, in the first part of this question, see, please try to observe. In the first part of this question, they are asking you that what is the velocity at some time point, that is 1 second, 2 seconds, 3 seconds. So exactly when they are asking you, at some point of time, basically you need to find the instantaneous velocity. Okay, that is the velocity at that instant of time. As I say, the velocity at some instant of time, the velocity is some instant of time whenever they are asking. So that means they are asking the instantaneous velocity. So you have to go for the way of differentiation, right? And when they are asking the average velocity, see, so it is the average velocity between 1 and 3 seconds. So if average also not would have written, you would have calculated the average velocity. That is why, see, you have to hold your concepts. Okay, you have to be holding your concepts well. Okay, so what is the average velocity between 1 and 3 seconds, or what is the velocity between 1 and 3 seconds? So they are referring to the average velocity because they have given you a span of time. Okay, a difference of time. Okay, so let's solve it. So sir, instantaneous velocity, sir, we very well know. Instantaneous velocity, sir, we very well know is S is equal to t square. So can we write, so V is equal to ds by dt, because we just came to know that the velocity, instantaneous velocity, is ds by dt. So what we can do, sir, we have learned to differentiate in the last session. Okay. Okay, so it is going to be V is equal to 2 times of t. V is equal to 2 times of t. Now, when I put t is equal to 1 second, so see, we have to find, now we have a function of t. So when I put t is equal to 1 second, or t is equal to 2 second, or t is equal to 3 second, definitely I'll be getting the value of instantaneous velocity, that is the value of velocities at these point of time. So it is going to be V is equal to 2, it is going to be V is equal to 4, and obviously the unit will be meter per second. Achha, don't get confused in the unit, sir. When we put in this t is in the unit of second. You don't have to think that way, because this is a function. A function is given. Okay, a function is given. Okay, so V is equal to 4 second. Then this is going to be 2t, that is with V is equal to going to be 6 meter per second. It is going to be 6 meter per second. I hope it is fine to everyone, right? I hope it is fine to everyone, right? Okay, okay, okay. So sir, we have got the instantaneous velocity. Very, very easy. Now can you try the second part of it? What is the average velocity between 1 and 3 seconds? Between 1 and 3 seconds. Now here many students make this mistake. So shall we take the average of the velocity at 1 and velocity at 3, because we call it like this. So V1, V2 and V3. So first of all, you don't have to write like that. We have to write like this. Okay. We have to write like this. So T at 1 second is this, 2 second is this, 3 second is this. Now what is the average velocity between 1 and 3 seconds? So guys, you don't have to do the average of 1 and 3, so you have to follow your procedure, what we have learned in the last section. So average velocity is total displacement upon total time. Okay, so don't you lose your formula. So average velocity, sir, we know average velocity, we know, sir, it is total displacement upon total time. Okay, it is what, sir? It is total displacement upon total time. So what is the total displacement between 1 to 3, or 1 and 3? So what is the total displacement, sir? It is going to be S3 minus S1. Okay, and this is going to be obviously 1 and 3, so that is going to be 2. Okay, so how it is S3 minus S1? See, understand this. So let's suppose we started our motion from here, that is the time when the time is 0. So time is never 0. It means the time 0 means that you have taken the reference from there. Okay, you have started your stopwatch from there. So if you go to run means health. Okay, so if you are good at making your health, so if you are going to run every day, so when you go to run, there are smart watches these days. You start them. Okay, so from there, they, you run for, let's say, 50 minutes. So 50 minutes, they say they start your time from 0 to 50 minutes. Okay, so this is obvious. So let's suppose you started from some reference time, and you have taken that time to be 0. So in 1 second, you have made some displacement. So let's suppose this is S1. In some more time, like in the second second, you have made, so after 2 seconds, this is your position. Displacement shows your position. Okay, so this is your S1. Oh, she's saying, okay, why is it that, beta? Is there something urgent? If there is something urgent, please watch the recording to it. Okay, no worries. This is a very light topic. See, it is just so we learned the differentiation in the last session, right? Now this is just the application of it. So lastly, we have differentiated the terms in X. Here we are differentiating the terms in T. So when you are going to watch it, definitely I'm very sure that you are going to understand it. Okay, don't worry. Now please think. So in 1 second we have reached this point. In 2 seconds we have reached this point. In 3 seconds we have reached to this point. In 3 seconds we have reached to this point. Okay, okay. Now between 1 to 2, what is the displacement? That is what we call as the change of displacement. No, so from here to here, what is the change in displacement, or what is the total displacement? So this is going to be the total displacement, right? Okay, Okay, so this is going to be the total displacement. So the total displacement is going to be S3 minus S1. The total displacement is going to be S3 minus S1, right? Okay. Okay, so we can put the value of S3 minus S1. So how, sir, we are going to calculate this S3? So we are having this S is equal to T square. So when S is equal to T square, so what is S3? That is displacement at the third of second. So at t is equal to 3, at t is equal to 3, obviously this s is going to be equal to 3 square, that is 9, right? And what is going to be, so this is at t is equal to 3 seconds. And now what is the t is going to be, what is at 1 second? So at 1 second, this is going to be equal to 1, okay? It could be of any unit, right? Welcome, Mohan. Welcome to the session, my dear. Okay. So now it is going to be S3 minus S1. So it will be 9 minus 1 by 2, that is 8 by 2, that is 4 meter per second. Okay. So I am assuming that the displacement are given in the terms of meter per second. Otherwise, what you can do, what is the right thing to do? So you must write 4 units because it can be in any unit. Okay. Okay. Mohan, you want to say something, my dear? Are you getting this thing? Okay. What we are doing here, we are trying to get the velocity from the displacement, my dear. ठीक है, डिस्प्लेसमेंट निकालने की कोशिश कर रहे हैं, वेलोसिटी सॉरी वेलोसिटी निकालने की कोशिश कर रहे हैं डिस्प्लेसमेंट से. So what we have learned that the instantaneous velocity is ds by dt. That means that when we are differentiating the displacement with respect to time, we are getting the instantaneous velocity. In the last session, I have explained about the basic of differentiation. So in this session, we will be, applying those concepts of differentiation, the mathematical tools to get some physical quantities, mostly velocity and acceleration. I hope it is fine to everyone. And we'll be doing some more question. You will get through the question. So let's suppose we have S is equal to t cube minus 6t square. Randomly, I have thought of this. So you have to now the velocity, find the velocity. Okay, okay, you just joined live. Wonderful. So, beta, you know what is, so are you following the lecture? So this is your first lecture of physics in our channel, in this channel. See, I'll just give you a brief explanation. See, what we are doing, we are into kinematics. Kinematics is what? It is the study of motion. So here we have to talk about distance, displacement, speed, velocity, acceleration, and jerk. Right? Are you getting my point? Okay. So now in all these things, so this is I think the fourth chapter of this particular topic. And in the first chapter, in the first session, you will get all these sessions on this channel. Okay. So basically, in the first session, we have come to understand what is the difference between distance and displacement, solve some problems, sorted it out. In the second session, we were talking about the average speed and the velocity. Afterwards, we have talked about the differentiation in the last session, and now I am using the concepts of differentiation to get the velocity out of the displacement. Okay, so do you have any idea, like you are good enough in differentiation? You know about the differentiation something? I don't want you to be very pro to it because see, in the NEET examination, just a small amount of differentiation will be required, like the small function. Okay, so basically, what is V? V is when you differentiate this S with respect to time. Okay, so when you watch the previous session, you are going to understand it, how it came to and what it basically refers to. Okay, for that you have to do some work, right? So now let's differentiate it and give me the velocity at time of 1 second and 3 seconds. Can you do that? Can you please try to do that? Yeah, let's try doing that. I'm very sure we can do it. So the very easily what we have to do, so we have to differentiate this function. So first of all, let's differentiate it. So let's say, sir, we know that velocity is ds by dt. Now this function is to be differentiated with respect to time. So it will become v is equal to 3t square minus 12t, right? 3t square minus 12t, right? Okay. Now we are asked about that find the velocity at t is equal to 1 second. So what we have to do? So at t is equal to 1 second, see it is very, very simple. We have to put, so from where this came out to be, so we know that the differentiation of, so last session we have seen this, d by dx x to the power n is equal to nx n minus 1. This is the standard formula. So we are just applying this formula. So when we are differentiating this t cube with respect to t, what it is going to be? Sir, n minus 1. So what is n? N is 3. So this is 3. N minus 1, that is 3 minus 1, that is 2. Similarly, 12t square, 6t square. So 6 is a constant. It will be at outside. Now t square, it will be 2t to the power 2 minus 1. That is 2t. So we'll get this. Now at t is equal to 1 second, what we have to do? So we have to put 1 here. So we'll be getting 3 minus 12. So this is going to be minus 9 units, right? Minus 9 units or minus 9 meter per second. If the unit of the velocity you consider as to be meter per second. Now what is the t? Now at t is equal to 3 seconds. Let's get it at t is equal to 3 seconds. Now if I write at t is equal to 3 seconds, you're going to put this t value in this v. So you are going to get 9, 3, that is 27, and this is going to be minus 36. So this is going to be minus 9 units. Oh sir, at 1 second and 3 seconds the velocity is coming out to be same. So what is your problem with that? If it is same, let it be the same. What is your problem? It's okay only. So can it happen? Yes, definitely. Why it cannot happen? It can happen. No problem at all. Okay. Okay. So we have written like this. Now please understand this. Let's put some more part to it. Now what you do? Find the let's say find the time when body is at rest. Okay, let's suppose that the body is at rest. So at some point of time the body may be at rest. So you have to find now that at what point of time the body is at rest. Can you do that? Can you do that? Please try to do it. The live student, can you please try it? I'm very sure if you try you can do it. Yes. Now, please understand it. So when we say that the body is at rest, when we say that the body is at rest, I'll write it here. So when we say that body is at rest, that means that the v is equal to 0. So when body is at rest, that means the velocity of the body is 0. So what we are going to do? So the velocity is 3t square minus 12t. So let's put it equal to 0. So from here, can I write it as this? This is going to be t, okay, t square minus 4t is equal to 0. So from here, t is going to be equal to 0 or t is going to be equal to 4. So basically at these 2 points, that is when the time is 0 and the one when the time is 4 units, basically your velocity is going to get 0. Your velocity is going to be 0. I hope it is fine to everyone. So your body is going to be at rest at 0 time and the time of 4 seconds. Clear? Okay. Okay. Now, if in this case that they are asking you, sir, what is the displacement? Now, if further they ask you, what is the displacement or what is the position? See, displacement gives you the position of the, position of the body as well. Are you getting my point? This displacement gives you the position of the body as well. So if we give you the position of this body, okay, so what is the position of this body, or what is the displacement of this body when the body is at rest? So basically, body is at rest at time is equal to 0 and 4 seconds. Okay, 4 units or 4 seconds. Let it be second now, or units, anything, doesn't matter. Now see what happens. So you are going to put it here. So at displacement is equal to 0 and s is equal to t cube. So t cube, that is 4 cube, okay, minus 6 into t squared, that is 6 into 4 square. 6 into 4 square. So this is going to be, so 4 cube, that is 4 cube, that is 64. 64 minus 16 into 6. So 16 into 6 is 16 into 6 is how much? I'm not very good at calculations. Okay, but I am a teacher, so I can. Acha, acha, Shreet, I understand. I understand. No worries. You can watch the the recording of it. It is not that hard a chapter. It's just we are going ahead of, we are applying the concepts of differentiation. Okay, so 64 minus 96, that is going to be minus 32 meter. That is going to be minus 32 meter. Oh, so displacement is in minus. What does that mean? Please understand this. So this, this shows the position of the body from some reference. Okay, from some reference. So normally we do like this now. This is plus, this is minus, this is plus, this is minus. Now see. So what it refers to be, so as is equal to minus 32 meters. So if we are talking that the body is on this x-axis, okay, so it means that it is minus 32. So it is minus 32 from this origin. We know this is the origin now. Okay, so this is the position. This is the position of it. Are you getting my point? This is the position of this particular body at this reference of time. Understood? That after 4 seconds, it is at a position of minus 32 from the origin. That is, it is behind the origin by 32. See, displacement never gives you the direction of motion. It gives you the position. And this, I'll be talking about it. Don't worry. Okay, I hope this much is fine to you. This much is fine to you. Now let's move to the one more question. Let's move to one more question. So let's have one more question there. So s is equal to 3t square. S is equal to 3t square, let's suppose, plus 4t plus 9. Just taking some simple expression. Simple expression. Okay. Okay. So we have learned the differentiation. If these are complicated to some extent also. Yeah. So if s is equal to 3t square plus 4t plus 9, so we need to find. Some technical issue. I'm sorry for that. Okay, let's continue. So we have s is equal to 3t square plus 4t plus 9. Now find the velocity. Find the velocity at t is equal to 2 seconds. At t is equal to 2 seconds. And let's suppose we also want to find an average velocity and average velocity between 1 to 4 seconds. Okay, okay, let's try it. Let's try it. Let's try it. How we can do it? Please go for it. Please go for it. What it is? Please sign. Seems to be incorrect. Very, very simple question. At t is equal to 2 seconds, we need to calculate first and then the average velocity. So first of all, sir, v is equal to, we know, ds by dt. So what is going to be the differentiation of it? It is going to be 6t plus 4. Okay, 6t plus 4. So at t is equal to 2 seconds, t is equal to 2 seconds. So at t is equal to 2 seconds, what is going to be the velocity? It is going to be 12. So we are putting the value of t plus 4, that is 16 meter per second. Is it fine, madam? So see, she said what we were talking about. So whenever we are to find the velocity at some point of time, whenever you are to find the velocity at some point of time, at some point of time, okay, okay, that is the instantaneous velocity. So whenever velocity is to be found at some point of time, that is the instantaneous velocity, and whenever it is to be found at some span of time, that is the average velocity, we know. Okay, so we are putting it 2, so we are getting 16 meter per second. Now what is the velocity between 1 to 4 seconds? 1 to 4 seconds. So sir, we understand that the velocity is change displacement upon change in time, right? Okay, okay, now what is the change in displacement? What is the displacement between 1 to 4 seconds? So it is going to be S4 upon S1. And what is the time between 1 to 4 seconds? So it happens to be in 3 seconds, isn't it? Do you agree to it or not? Okay. Sir, how come, sir? Let us understand it again. Now see, what do we mean by this S4 and S1? So see, when you start with 0 time, after 1 second, the displacement is S1. After 2 seconds, the displacement is S2. Okay. After 3 seconds, the displacement is S3. And after 4 seconds, the displacement is S4. After 4 seconds, the displacement is S4. Okay. Displacement is S4. Okay. Okay. So what is the displacement between 1 and 4? So it is going to be the displacement between 1 and 4. Now that is S4 minus S1. Okay. So how we are going to get S4? So we will put the value of S4 here. So if I put t is equal to 4, we are going to get it. So 3 into 16 plus 4 into 4 plus 9. So how we are going to get this? So this is 48. This is 48 plus 16. So this is going to be 64. 64 plus 9, that is 73. So can we write here 73? And the time is 3 seconds. Obviously between 1 and 4, the time difference is 7 by 3. So sorry, S1 is also there. So what is going to be the S1? So S1 we are going to put time is equal to 1. So this is 3 plus 4 plus 9. 3 plus 4 plus 9. So this is going to be 16. This is going to be 16. So 73 minus 16 by 3. This is per meter per second. Okay. Okay, Shikha. Okay, so did you get this concept? See, whenever we want to have the velocity at some point of time, that is nothing but the instantaneous velocity. And whenever you want the velocity in some span of time, in a span of time, you need to have it, that is the average velocity. Are you getting my point? Okay, so whenever instantaneous velocity is to be found, it is ds by dt. And whenever average velocity is to be found, it is delta s by delta t. Understood? Understood? So see, again, I'll be repeating this. So we have the displacement as 3t square plus 4t plus 9. And we want to find the velocity at t is equal to 2 seconds. Okay, and the average velocity between 1 to 4 seconds. So at t is equal to 2 seconds, so this is the reference that you are going to calculate the instantaneous velocity. And instantaneous velocity is dv by dt, because when you are calculating the instantaneous velocity, the time difference is reduced to infinitely small. Are you getting my point? So see, when we differentiate it ds by dt, so it is going to be 6t plus 4. This is going to be v. Okay. And what is when you are when you want to find the velocity at t is equal to 2 seconds, you can put 2 here. Okay, so when you put t is equal to 2, you are going to get velocity as 16 meter per second, right? So this is the instantaneous velocity. Understood? Now you want to find the average velocity between 1 to 4. So what is the average velocity? Average velocity, we know total displacement upon total time, right? Total displacement upon total time, that is delta s by delta t. Now what is the delta s? So you are asked about 1 to 4, between the displacement between 1 and 4. So in a 1 second, what could be the displacement? Let's suppose in 1 second the displacement is s1. So if we started from 0, okay, in 1 second let the displacement be s1. So you have measured it from some reference point. So this is s1. Now in 2 seconds, you have reached this s2 point, it's s2 position. In 3 seconds, you reach this s3 position. In 4 seconds, you reach this s4 position. Okay. Now what is your change in displacement? What is your change in displacement? So your change in displacement going to be s4 minus s1. Okay. Okay. This is now from 1 to 4. So this is delta S. So S4 minus S1. So to get S4 minus S1, so S4 is the displacement. This is nothing but the displacement at t is equal to 4. Okay. Unit. It can be second. It can be any unit. So I'll say unit. Now S at t is equal to 1. So this is S at t is equal to 1. You can have the difference of both and divided by delta t, that is 3 seconds, and you are going to get the average velocity. So it is going to be 73 minus 16. Okay, so that is 57 by 3. Yeah, it is very easy, no? So see, when you know the differentiation, this is very easy. So in the whole lecture, we are doing the same thing. Okay, we are doing the same thing. Okay, okay. I hope this is fine to everyone. Okay, same way, sign. We are done this thing. See, all the numericals are the same. We just talked about something of the slope. This thing you already know. You just have to watch it. Just you watch it once, it will be fine to you. Okay, we have just solved some problems of the same kind. Okay, now let's talk about the acceleration. Okay, let's talk about the acceleration. So acceleration is what? It is the rate of change of velocity. Sir, we know na, this is the rate of change of velocity. Okay. Okay. So now acceleration is what? So it is delta v upon delta t. It is delta v upon delta t. Now you tell me, when I'm using this thing delta v upon delta t, what it would be? It would be average acceleration, because we are talking in some bigger frame of time, right? So this is average acceleration. But sir, if we want the instantaneous acceleration, okay, instantaneous acceleration is nothing but the acceleration at some point of time. Like if you are asked about that, what is the acceleration at 2 seconds, exactly at 2 seconds, not between these two times. Okay, what is the acceleration at the particular point of time? Okay, so that is the instantaneous acceleration, and there you have to reduce your time to an infinitely small quantity, and it will become dv by dt. Now you know what to do. You know what to do. Very, very simple, sir. Very, very simple. So a is dv by dt. So lastly, what we have learned? So dy by dx is the slope of the curve in y versus x axis. Now in the same way, dv by dt is nothing but the slope of the curve in velocity versus time curve. Yes or no? Bolo. Slope of v versus t curve. Okay. Okay. In the same way, so you can relate with that now. You can relate with that. Okay. Now let's suppose I am asking you. So we are having just for the sake, we are having some displacement and time, some displacement and time, and this is the curve like this. This is the curve like this. Okay. Okay. So can I say that it is having a constant acceleration? What do you say? Is it having a constant acceleration? Can we say so? Can we say so? Please answer me. No, sir, we cannot say so. Please understand that this is displacement in time. No. So from here we cannot comment on it. We can say that the velocity is constant because we know that velocity is ds by dt. So velocity is the slope of the curve. So we can say velocity is constant. So velocity is constant. That means acceleration is zero. See, this is how you have to relate in the curves. Are you getting my point? Okay, lately we are going to see this in upcoming lessons, upcoming chapters. So this is ds by dt. Okay, and since velocity is constant, so acceleration is zero, isn't it? When velocity is not changing, the acceleration is zero. Understood? Understood? Okay, you got that. Now similarly, if we say that we have a t versus v curve, velocity versus time curve, so from here we can comment that here the acceleration is constant because we know acceleration is the slope of v versus t curve. So this is something very important, isn't it? So acceleration is the slope of v versus t curve. Okay. Okay, so displacement versus time curve gives you the velocity. Its slope gives you the velocity, and velocity versus time curve slope give you the acceleration. I hope it is fine to everyone. Please answer me. Please answer me. Yes or no? Yeah, she said. Do you want to say something on this? Any issue? Any issue? Okay. Now, similarly, from seeing the velocity versus time curve, you can see. So, if the velocity time curve goes like this, please observe. See, in upcoming sessions, we are going to use all these concepts, but just I am going to give you a glimpse of it. Now, if this is the velocity versus time curve, can you comment what is happening to the acceleration with respect to time? Can you comment on that? Time के साथ acceleration में क्या हो रहा है? बताइए. What is happening to acceleration with respect to time? See, these are very frequently asked questions. These concepts are of utmost importance, right? Okay, please tell me. Please tell me. Acceleration is changing. Okay, that's fine. What else? Acceleration is changing, sir. Why it is changing, sir? Because we can see it is a curve, and we very well know that in a curve, when we make tangents from different points, the slope is going to be different, right? Okay, so yes, the acceleration is increasing. Sir, how come we see that? How can we see that? So, sir, let's suppose this is a point and we are placing a tangent like this. So, let's suppose this is theta 1. Now, see, if I place the tangent from here, this is theta 2. So, clearly theta 2 is greater than theta 1. Now, when theta 2 is greater than theta 1, that is tan theta 2 is greater than tan theta 1. And tan theta, we know that this is the slope. So, see, everything is interrelated, na? Right? So, this tan theta is nothing but dv by dt. Dv by dt. So can we say dv by dt is increasing? That means, and dv by dt is nothing but the acceleration. So acceleration is increasing. So this is how these concepts you can interpret later in terms of the graph. Okay. Okay. So when we are going to come to that thing, we are going to talk about it extensively, but still you have some insight to it. Do you agree to it? Yes or no? Please tell me. Okay. Now, ultimately, let's suppose we have some s with us. Okay. We have some displacement with us. So velocity we can get as ds by dt. Okay. Acceleration we can get as dv by dt. That is d2s by dt square. d2s by dt square. Okay. Okay. So this is also the acceleration. That is d2 square by dt square. What is d2 square by dt square? d2s by dt square. So it is double differentiation of the displacement with respect to time. Last session also we have spoken about it. Now, what is the use? So if displacement is differentiated twice with respect to time, you are going to get the acceleration. Understand? Now, what is the jerk? Okay, so this is very unlikely that they ask you this, but just one information. So if acceleration is differentiated with respect to time, you are going to get the jerk, and that is nothing but when you triple differentiate the displacement function with respect to time. Okay, I hope it is fine to each of you. Those who are watching the recording also, you can also ask me the questions in the comment. I'll be happy to answer them. Yeah. Okay. Now let's solve some questions. So V is equal to, where is Shivesh today? So V is equal to 2t square minus 4t. Okay, 2t square minus 4t. So find acceleration at t is equal to 3 seconds. T is equal to 3 seconds and find acceleration at t is equal to 3 seconds and find, this is not 5, you remember, this is 3 seconds. As sometimes my s look like, so I'll write it like this. Okay, otherwise the students get confused. Acha acha, he had Harshal class. Okay, it is still running. And find average acceleration, average acceleration. I'll just average acceleration from 0 to 3 seconds. Okay, 0 to 3 seconds. Okay, can you please do it? Can you please do it? Very good. And what is the average? What about the average? What about the average? Average between 0 to 3 seconds. So the very simply we can get this acceleration at 3 seconds because here they are asking us the instantaneous acceleration. So instantaneous acceleration is dv by dt, dv by dt. So this is going to be dv by dt. So that is 4t minus 4. Okay. And what is going to be the acceleration at, so I'll just see. Yeah, wonderful. So this is going to be, so when we are putting t is equal to 3 seconds in this, we are going to get acceleration as 4 3 12 minus 4, that is 8 meter per second square. Wonderful. Or we must write it as units. Okay, because we don't know whether this is in meter or something, but you can use meter per second. So you are getting my point now. You are normally, you will see that in examination it is given that acceleration is 8 units. So units, because we are not clear whether it is meter per second square, kilometer per second square, or what. Okay. Okay, I hope it is fine to everyone. Now, what is the average acceleration from 0 to 3 seconds? So we know average is delta v upon delta t. So delta v upon delta t, that is, so what we can write. So see, velocity is a vector. So let me not enter into the vector. So can I write like this, v3 minus v0 upon t3 minus t0? So that is, only 3 seconds, right? So delta t is 0 to 3, that is 3. Okay, but this is not very right way to write the velocity though. Okay, because it is a vector, it should be written like this. So normally you write it like v2 minus v1. So velocity, v2 is velocity at 3 seconds. You can write it as final velocity minus initial velocity or anything like that. But I think you are getting the context, right? Why I am writing this as v3 here? Because at 3 seconds, so you can put 3 seconds here. So what is the v3? what is the V3? So what is velocity? This is velocity at 3 seconds. Okay, so 2 into 3, 3, 9 minus 4 into 3. So this is going to be 27 minus 12. So 27 minus 12. So 27 minus 12 is how much? It is 16, right? Okay, okay, so 50, right? So it 27, 18 minus 12. Sorry, my bad. 6. It is 18 minus 12. That is 6. Okay, so V3 is 6 meter per second. Now, what is V0? So V0 is when you are putting t is equal to 0. So t is equal to 0. So this is 0. This is 0. So V3 minus V0, it is 6 minus 0 by 3. Yeah, sorry. I already have corrected. So this is 2 meter per second. Okay, 2 meter per second. So, you got this concept, right? Easy? Easy? Yes or no? So we can solve, n number of problems on this concept. N number of problems we can do at this concept. But what it seems to me that you will be able to do, because it is simple differentiation that we are doing. Right, guys? Yes or no? Please answer me. Yeah? Okay. Now there is something very easy, very easy. Now, sir, we have to understand some integration too. Because see, right now what we have done, we have moved from displacement to velocity, then to acceleration. What if we have to move in the reverse direction from acceleration to velocity to displacement? So for that we will be requiring some integration. But integration we are going to do in the next section of mathematical tools. Okay, so the next section I'll be speaking about the integration. But before that, let me tell you some brief concepts some more. So let us talk a little about the direction. Okay, the direction of motion. Okay, direction of motion. So we'll be needing this also lately. So we have some time here, so we can talk about it, and we can talk about something else also. So see. So what is the direction of motion? Now, if I say that the displacement is, let's suppose, minus 5 meter, displacement is, let's suppose, plus 5 meter. Okay, let me not use this 5, otherwise you will get confused. Let's say displacement is minus 7 meter, displacement is plus 7 meter, and displacement is 0 meter. Now, can you, yeah, don't worry, I'll come up with the integration. I'll tell you everything what is required in one session, like the differentiation we did now. Same way we will do the integration. Okay, nothing to worry about. Okay, now if I ask you that displacement is minus 7 meter plus 7 meter or 0 meter, 0 meter, now can you tell me this, that what is the direction of motion in the first case, second case, and the third case? Can you tell me that? Can you try to tell me? Can you try to tell me? Mhm. No, direction of motion. No, direction of motion I am asking. Can you tell me the direction of motion from it? So, no, sir, we cannot tell the direction of motion. Okay. See, please understand this. So, when we see this minus, we plus, so we try to interpret the direction of motion, but this doesn't give the direction of motion. Basically, as you said, so sir, minus 7 means that from some origin. So, the normal system we use like this, plus x plus y minus y. Ha. It's just the position. It's just the position. So this minus 7 meter is here somewhere, right? This is your minus 7. Okay, this is your minus 7. Okay, now what does it mean? That someone is standing at this position. Okay, Now, this body may move in this direction, may move in this direction. By seeing this thing, you have no idea that from this position it is moving in the positive direction or negative direction. So, one thing that we must understand that from the sign of the displacement, we never come to know the direction of motion. This is going to be helpful in the curves again. Are you getting my point? Yes or no? Because see, like this. So when we write this plus 7, so that means that you are somewhere here. You are somewhere here at plus 7, right? Now from here you can move in this direction, you can move in this direction. Who knows, right? There is no information. Now similarly, this can be 0. Now similarly, this could be 0. So 0 could be here, 0 could be here. Okay, so 0 could be here. What does that mean? You can move in any of the direction, right? So see, displacement never gives the direction of motion, but velocity do. So if written that velocity is 7 plus 7 meter per second, or velocity is minus 7 meter per second, now this from this information you can tell that in this, when velocity is plus 7 meter per second, so if this is plus x, this is minus x, so you can say that your body is moving in positive x direction. Yes or no? Okay. Okay. Are you getting my point? Please answer me. Yeah. Yeah. Please answer me. Right. Now, similarly, when we say velocity is minus 7 meter per second, so as per this sign convention, you can say that your body is moving in the negative x direction. Okay, so velocity sign gives the direction of motion, displacement sign doesn't give the direction of motion. Understood? Understood? Understood, sir. What about the sign of acceleration? So if acceleration is positive, can you comment about the, so if acceleration is positive, what does that refers to? What will happen to velocity? If acceleration is positive, what will happen to velocity? Please try to understand. This is physics. See, physics, you have to use your brain each of the time, right? Your brain has to be in on mode at all point of time. Can you please tell me? Can you please tell me? Wrong answer. Now, 99% time when I ask this to students, so what happens if acceleration is positive? They say velocity increases. Now, please understand this. Let me say that the velocity is minus 7 meter per second. Okay. And acceleration is positive. Now, in that case, the velocity is going to decrease now, isn't it? Because velocity is in negative direction and acceleration is in positive direction. Are you getting my point? So basically what is going to happen, acceleration, now to be simplified, see, we all know something called as retardation. If velocity is in plus direction, plus 7, that is you are moving in this direction, plus x direction, and acceleration is negative, you right away say that it is retardation and velocity is going to decrease. So similarly, when velocity is in negative direction, that is something is moving in minus x direction and acceleration is positive, that means your velocity is going to decrease. Are you getting my point? Yes or no? Right? Okay. So when you are seeing that velocity is increasing or decreasing, you are not only seeing the direction, not only seeing the sign of the acceleration, but you are also seeing the sign of the velocity. Is that clear or not? Yes or no? Please answer me. Please answer me. What do you say? Right or wrong? Wonderful. Now let's talk a little further. So let's suppose we have a question. Okay, let me make one. T cube minus 6t square plus 90. Now can you get me the velocity at t is equal to 2 seconds and acceleration at t is equal to 3 seconds? Okay. Can you do that? Okay. And can you comment upon the direction of motion and whether the body velocity is going to increase or decrease? Can you do that for me? Yeah, please try to do that. Please do that. Are you sure? I think some mistake you may have done. Now, let me do it. So we have velocity is equal to ds by dt, we know. So it is going to be 3t square minus 12t plus 9, right? Plus 9. So if we put, yeah, okay, I'll come to it. So 3t square, so 3 into 2, 4, 12 minus 24 plus 9. Plus 9. So this is going to be how much? This is going to be how much? So it is going to be minus 3 meter per second, isn't it? Okay. Yes or no? So you say minus 21. I think you have missed something. Yes or no? Right? Sign? Yes or no? Yeah, it is plus 9. It is plus 9 actually. No worries, you got the concept. Now we'll talk about it. So let's talk about acceleration. So for acceleration, I have to differentiate this velocity with respect to time. So when we do it, so it is going to be 60 minus 12. So t is equal to 2. Oh, sorry, at 3 seconds we have to find. So t is equal to when 3. So it is 18 minus 12. That is 6 meter per second square. So it is positive. Okay. Now, what is the interpretation to it? How can you imagine this physically? Okay. In the world of physics, imagination is also very important. So, what is the imagination? That somebody might have started from some reference and now it is moving in the negative, it is having a motion in the negative direction. But if the acceleration is positive, so if the acceleration is in this direction, so it is retarding in the negative direction. Are you getting my point? It is retarding in the negative direction. Understood? Understood? So simply see where acceleration and velocity are having the different signs, so the speed is going to decrease. Understood, my dear? Understood? Okay? Okay? Right? Okay? So now there can be further more questions add on to this. What can be more addition to it? So you can be out asked about. So what is the acceleration? What is the acceleration when body is at rest? Okay, जब body rest पे है तो acceleration क्या है? What is the acceleration when body is at rest? Please do it. Can you try it? Can you try it? Can you try it, please? What is the acceleration when body is at rest? Rest means the velocity is zero. Rest means the velocity is zero. Please try it. Those who are watching the recorded session, they may. I'm waiting for the live students to respond on this, so you can do some forward thing, or you can solve right away with the flow of the video, and you can watch it. Right? So what does that mean? How we can solve this question? Can you please try to solve this question? Yeah. Plus 6 and minus. Let's see. So now what is the acceleration? So what we can do, sir, V is equal to, we know, so 3t square minus 12t plus 9 is equal to 0. Okay, plus 9 is equal to 0, right? Plus 9 is equal to 0. So we can have it, so we can sort this. This is a quadratic equation. We know to solve quadratic equation, right? Okay, so we can write it as t square minus 4t plus 3 is equal to 0. So basically it will become t minus 3 and t minus 1, isn't it? Okay, when you see the roots, yeah. So it is at rest at 1 second and 3 seconds. It is at rest at 1 second and 3 seconds. So when you see at 1 second, when you see this at 1 second, so what is going to be the acceleration? So acceleration is 6t minus 12. 6t minus 12. Now acceleration at 1 second, it is going to be 6 minus 12. That is minus 6 meter per second square. And what is the acceleration at 3 seconds? It is going to be 18 minus 12, that is plus 6 meter per second square. Plus 6 meter per second square. Is it fine? Is it fine? So will you be able to play with all these differentiation thing? Yes or no? Just tell me one thing. You can solve n number of previous year question on this concept from after watching the today's session. Can you play with all these things? Yes or no? Yeah, reaching, playing with all this thing. Yes or no? Please answer me. All the live students. I hope this is clear. So let me move to the one more concept. Just last concept for the day. Okay, just one moment. I'll have to do some add-on. Yeah. Okay. No. That will that is so you have to Shita, if you are making the mistakes, so that is nothing to worry about. Basically you have to practice more. Once you practice more and you have to increase your concentration in solving the question, this will happen, don't worry. Okay, now let us come with one more concept. So see, let's suppose we have s is equal to t square minus 4. Okay, so if I ask you what is displacement at 1 second, what is displacement at 1 second? So the displacement at 1 second. So what you will write it? So we'll write it as s1. So it is going to be 1 minus 4. So whatever it is going to be 1 minus 4, isn't it? Okay. Okay. Or if I ask you what is displacement at 3 seconds, displacement at 3 seconds. So it is going to be s is equal to 9 minus 4. That is 5 meter or 5 unit, isn't it? Oh, sir, this is very easy now. We understand. So if I ask you what is the displacement in the third second? Okay, so sometimes what we got, see, physics, one challenge in physics is that we must understand the language of the problem as well. Are you getting my point? So we must understand the language of the problem as well. Okay. Okay, we must understand the language of the problem as well, because sometimes we get trapped in the language. So unless you understood the question well, you will not be able to answer it. Okay. Okay, now what is the displacement in third second? So it means what? So I explained this previously also. So what is the third meaning? Okay, so the displacement in the third second is, sir, s3 minus s2. Okay, s3 minus s2. Do you get this point or not? So we have started from some point. In 1 second, let's suppose the displacement is this. So this is s1. This is the displacement in 1 second. Okay. This is the displacement from this origin to the second. And this is the displacement at exactly the third second. Exactly in 3 seconds, actually. Exactly in 3 seconds. Okay, this is S3. This is S3. Are you getting my point? Now, what is going to be the displacement in the third second? So it is asking you that what is the displacement in the third second. So this is going to be this thing. Na? Let's suppose this is X. So this is going to be this. Na? Do you get this point or not? Please answer me. Okay, please answer me. This is fine now. If they ask you displacement in third second, fourth second, fifth second, 8 second, 10 second, yes or no? Yes or no? So basically, if we want to generalize this as given in the book, so displacement in nth second, we can write displacement in nth second. Okay, displacement in nth second is going to be how much? So let's write it as nth. Okay, it is going to be Sn minus Sn minus 1. As simple as that. Okay, like what is the displacement in the 10th second? So you can write S10 minus S9. Right? Right? Clear? Very, very simple now. Very, very simple. So guys, this is going to be all. So whatever concept I wanted to tell you today, now that are completed. Now from moving, now to move. So see, if you see the direction, so see, I'll tell you, when you are understanding a subject in a good way, how you can judge that, especially in the subjects like physics. So now if you can think that what should be the next concept, then you are reading that subject in the right manner, right? Now you have said you what we have done, so we have reached from displacement to velocity, then to acceleration. We have done some play with all these things. So what should be the next thing? So sir, we learn to reach velocity, acceleration from displacement. Now we must learn to move in the reverse direction. That what if we know the velocity, or what if we know the acceleration, how to move in the backward direction? That is the question. Now for that you will be requiring some concepts of integration. So I'll be coming up with the next session in which I'll be telling you the integration, the concepts of integration. Understood? I'll be telling you the concepts of integration. Okay. Okay. And also after that we'll do one session of kinematics. Then I'll start with the vectors also at the same time. Vectors, we know that it is a motion in a plane thing, but some concepts of vector will be required here also, because afterwards we'll soon going to reach to the relative velocity. So basically I'm merging these two chapters now. Okay, it will improve our speed also, and it will give you more concepts day by day. Okay, sounds good. Yeah. Okay. Okay, so very soon we'll be coming up with that also. I think after two sessions, the third session will be of vectors. Okay, and afterwards we'll move with the kinematics. So we are going to mix these two NCRT chapters, that is motion in a straight line and motion in a plane. Okay, okay. So guys, let's keep it to this point in today's session. I hope you have understood all the concepts of today. So with this, yeah. So the dimension of nth will be L. Definitely it will be L. It is the displacement. Now. What is the displacement? What is the dimension of displacement? Lt minus 1 in nth second. The displacement in nth second. It is L only. Na? Okay. Which book says it is Lt minus 1? They say to this reference at times, you know, basically this is the displacement given in a second. So when we say displacement in nth second, okay, this displacement happens to be per second, isn't it? Displacement happens to be per second. So in that sense, it is LT minus 1. Okay. But it again depends upon in what reference you are seeing it. Are you getting my point? So when we say different displacement in nth second, is kind of a displacement per second, isn't it? Do you agree? So it is displacement per second. So its dimension in that way is LT minus 1. But if you are seeing the absolute value of it, then the dimension is L. Okay. Don't get confused. Okay. So see, it is basically many authors write the things about in a way they understand it. Understood? Okay. So I hope all the doubts are clear and we have learned something from this session. So guys, I'm going to see you in the next session with I'm going to come up with the integration. I'm going to come up in the integration. Yeah, we will be Shita is talking about it. Don't worry. Okay, because I have the next session to take. Yeah. So can we wrap it up? Okay. Yeah. Okay. Wonderful. So, guys, we have learned in this session about the instantaneous velocity acceleration, the use of differentiation in kinematics. So, in the next session, we are going to come up with the integration. So, till then, thank you very much. Have a good day. And please don't forget to subscribe the channel and like it. And please share it to your friends also so that they can also come and learn physics, biology at this channel. Okay. So, with this, thank you very much. Have a good day.